Specifically, what we're looking at is today what the environmental impact of an AI query is, and also what the improvement over the last year has been.
We've had a 20 to even more year history of publishing data in this space, showing what our power usage effectiveness ratio is for data centers. We want to drive that ratio as close to 1 as possible. People have understandably, concerns about, is this going to be using a lot of energy? Is it hurting the planet in various ways through carbon emissions?
What we see is the most comprehensive approach to measuring the energy consumption for AI across the full stack. So it's not just looking at the models, it's not just looking at the hardware, it's also looking at the infrastructure and how everything gets orchestrated.
There have been other efforts that look at the inference cost of various AI models. In some cases, the methodology that was used there is not really that close to what a production serving system uses, so the numbers usually end up being much higher because they don't incorporate things like, say, speculative decoding or large batching of requests into making the overall system much more efficient.
We're actually measuring the energy consumption of these AI models on Google's data centers. And what that means is that we're not just measuring the power from the chips, we're actually looking at the utilized TPUs and GPUs in Google's system.
People were wondering, like, if I do a Gemini query, is that equivalent to driving a car 1,000 miles? And the answer is absolutely not. Like, the data we gathered shows the carbon emissions are actually quite small.
The energy consumption and carbon emissions and water consumption were actually a lot lower than what we've been seeing in some of the public estimates.
AI models are scaling so quickly, there needs to be good metrics today to make sure that we're building these models in the most efficient way that we can.